Okay, in the previous video we ran our binary logistic regression predicting the likelihood of a client or a student terminating counseling services 2 months after seeking them. So at any rate, our terminate variable was coded 0 for those individuals who did not terminate within 2 months, 1 being those individuals who did. And we included avoidance of disclosure, symptom severity, and sex as predictors. And we have year in school as a predictor. We didn't include it previously for pedagogical purposes, but now we're going to include it to kind of show you how to use the categorical option in SPSS. So year is a categorical variable. It has more than 2 levels, so it's not a dummy variable. Basically, if you want to run a regression analysis with a categorical variable, you have to convert that categorical variable into a set of dummy variables, which allows for comparisons between a baseline group and the remaining groups. Essentially, this translates into a set of orthogonal contrasts. So, if in SPSS, if I go to binary logistic and add year, the fact of the matter is that sex, as I said before, is already dummy coded. So there's no need to treat this as a categorical factor and run it that way. It's already been dummy coded. There's only one categorical variable that's dummy coded in this case. Year would actually include multiple dummy coded variables. And basically, when you're creating dummy coded variables, the number of dummy coded variables is equal to the number of groups minus 1. So, I could do this manually if I wanted to. I could create a set of dummy variables that basically have a set of zeros and ones on them to distinguish those individuals who are freshmen, sophomore, junior, and seniors. I could do this manually, but that's a real pain in the neck. So the nice thing about SPSS logistic option here, if I click on categorical, I can ask the computer to do that for me. So that's essentially what I'm going to do. I'm going to go ahead and move year over, click on categorical, and then say, all right, year, I want this to be treated as a categorical covariate. And so it's going to create a set of dummy variables. Now, if I'm doing this, I have to essentially decide on which group is going to be a baseline category against which all the other groups are compared. So I can assign the reference category or the baseline category to be the last group. If that's the case, then SPSS will treat the seniors, which are coded 4, as the baseline or reference category. Or I could click on first, and the freshmen will be treated as the reference category. And I'm just going to go ahead and leave it with the freshmen as the baseline or the reference category. So I've clicked on that, and then I have to click on change. If I don't, the option is not going to hold. So I have to click on change, and now we've specified that SPSS is going to create dummy variables, and the reference category is going to be the freshman. And that group is actually going to have zeros coded across my dummy variables. So I'm going to click on continue. If we look under options here, our save options, we've got our probabilities, group membership as before. Options, we'll leave those pretty much as we did before. And now I click on OK. And so in this case, you'll notice that it talks about the categorical variable coding. So in other words, these right here, this is we have essentially 1, 2, 3 dummy coded variables. And you can see that the freshmen, which were coded 1 on the original year variable, they are assigned codes of 0, 0, 0 across the 3 dummy variables. The sophomores, which are coded 2 on the original year variable, they're assigned codes of 1, 0, 0 across the 3 dummy variables. So in other words, as you can see, well, actually, I won't go there quite yet. For the juniors, which were coded 3 on the original dummy variable, they are assigned dummy coded values of 0, 1, and 0 for the 3 dummy variables. And then the seniors were assigned codes of 0, 0, 1 for the 3 dummy variables. So essentially, each dummy variable will allow a comparison of one of the 3 remaining groups against the baseline group, which contains the freshmen. Okay, so scrolling down, again we have our beginning block. This is our essentially reflecting the classifications related to a null model. As you can see, really the null model in and of itself doesn't contain a whole lot of useful information. This is just saying that, essentially, that 56% of our distribution was made up of those individuals who did not terminate. So that's basically what we have there. So kind of moving on and looking at the block 1, and so now we have our model chi-square, which again, this is representing the degree of improvement and fit over a null model. So if this is significant, this means that we have a significant improvement in fit over the null. And so obviously in this case, that's what it appears that we have. When we look at the pseudo R-square values, you can see that the R-squares are ranging between 0.48 and 0.646. So we might say that we're accounting for about 48 to roughly 65% of the variance in the dependent variable. But again, these are pseudo R-squares, and they're being used as an analogy to least squares R-square. And in fact, I am going to use my preferred method that Tabashnik and Fidel used, which is compute the phi coefficient. So we'll use predicted group and terminate here. So I'll calculate the phi coefficient and then essentially square it. So roughly 47.2% of the variance in the actual observed group membership was accounted for by the predictors. So at any rate, it looks like we didn't really have that much of a change by adding in the year variable. It looks like we're very similar in terms of the variance accounted for to what we had seen previously in the other video. The Hosmer-Limashow test, you can see it was not statistically significant, indicating that we actually have a good fitting model. So really, we've got pretty good evidence based on the chi-square fit over a null model, the R-square values, and then the Hosmer-Limashow test. All those are indicating that we have good fit. You see, actually, in terms of our classification table, that we didn't really improve in terms of our accuracy as a result of adding in the year variables. So we have exactly the same accuracy and classification that we had previously discussed when year was not included. If we look at the variables in the equation, you can see that we have essentially avoidance of disclosure is still a significant predictor. Symptom severity was also a significant predictor. So again, as scores increase on avoidance of disclosure, the likelihood of terminating within the first 2 months is increasing. And you can see that the odds increase by a factor of 1.46. For symptom severity, you see that as scores increase on symptom severity, the likelihood of terminating within the first 2 months is actually decreasing, and the change in odds is about is basically the odds are being multiplied by 0.71, meaning that the odds are actually decreasing by a factor of 0.71 for every increase on symptom severity. For sex, we see, again, we have a negative relationship, meaning that essentially females are less likely to terminate within the first 2 months. that difference was not statistically significant. With respect to the year variable, essentially we have 3 dummy variables that incorporate the information in the original year variable. So what we have for this first dummy variable, this is a comparison between the sophomores and the freshmen. And so essentially what this is telling us is that the sophomores, which were in the group that was coded 1 on this particular dummy variable, are less likely to terminate within the first 2 months than the freshmen. But nevertheless, you see that difference was not statistically significant. Even though the odds of the sophomore terminating is considerably less than that of the odds for freshmen. For the comparison between juniors and freshmen, you can see also a negative relationship, meaning that again, for this dummy coded variable right here, the juniors would be coded 1, and you can see for this comparison here that the juniors are less likely to terminate within the first 2 months than the freshmen. Again, this comparison was not statistically significant. As you can see, with 2 of our comparisons right here, no statistically significant differences. For the third one, you see that when you compare the seniors against the freshmen, you see that the seniors were less likely to terminate within the first 2 months than the freshmen. But again, that difference was not statistically significant. So, as you can see, really it appears that overall, by adding in the year variable, or the dummy coded variables that contain the information about year, didn't do much in the way of improving the fit of our model. And we can actually see this play out a little bit more explicitly if we run a hierarchical multiple regression. A hierarchical logistic regression. So I'm going to go to regression, binary logistic, and in this case I'm going to take year out here because we were using a simultaneous entry previously. So I'm going to make this a hierarchical logistic regression by clicking on next, and for the next block variable that's entered was going to be year. So I'm going to go back and I have to re-specify, well, I guess all this was actually already set. So first is still the category. I'm just going to make absolutely sure everything takes, and I'll click on OK. And so in this case right here, you'll notice we've got block 0, which is the null, block 1, which is containing the predictors of avoidance of disclosure and symptom severity and sex, and then block 2, where we enter our dummy coded variables for year 1, our comparisons between sophomores and freshmen, junior and freshmen, and seniors and freshmen. So kind of going back and looking at our block 1, this was basically, the fit is exactly the same as what we had previously in the first video. So we had a significant improvement in fit over the null model. Our R-square values were quite high. Our Hosmer-Lemichaud test was was not significant, indicating a good fit. Our overall classification rate was good, and we saw that avoidance of disclosure and symptom severity were significant predictors, but not sex. When we look at block 2 here, now you'll notice that you've got a little bit difference in some of these chi-square values. So you have the model chi-square is reflecting the inclusion of the dummy-coded year variables. So this is reflecting all of the predictors. The step and block chi-squares are reflecting the question of, is there a significant improvement from the previous model that had only these three predictors, and the current model that includes all of the predictors. And so as you can see, there was not a statistically significant improvement in fit between the two models. So even though the global fit of the model relative to a null was statistically significant, the change in fit from the previous model to the current model was not statistically significant. And in fact, looking back at our R-square values or pseudo R-square values, you can see that those values right here are not very much different from what we had previously. So we're not really adding any explanatory power by adding in the year variable. The Hosmer-Liebenschau test is, again, just a general test of overall fit. And, so yeah, even with the inclusion of the apparently non-relevant year variable, we still are doing a good job in terms of fitting the model to the data. So clearly by adding in the predictor and not having a significant improvement in fit, we would not expect our classification accuracy rate to improve either, so it doesn't. So again, when we look at the variables in the equation right here, these results mirror the results that we saw earlier right here in the model that we ran first in this particular video. So once again, it appears that avoidance of disclosure and symptom severity are significant predictors of the likelihood of terminating within the first 2 months, whereas sex and year do not appear to be significant contributing factors.